Okay, now this is the second YouTube video on linear regression. We're still looking at the same data set as the first one. So again, we're looking at the relationship between speed and distance to stop for cars. We've got 50 observations. These are the speeds and these are the corresponding stopping distance. What we want to do is we want to calculate a 95% confidence interval and then a 95% prediction interval for the stopping distances with a car going at 15 miles per hour. So let's have a look at the main formula I'm going to need. So I've got my confidence interval and my prediction interval. So here you've got your point estimate. So this is taking your linear regression model and putting in your x0, so in our case our 15. Then here is our standard error term for the confidence interval, and here's the standard error for the prediction interval. Notice the main difference is here you've got this 1 plus, which you don't have here. So this means we're going to have to get a cutoff point. We're going to need to get the SE, which gives the mean square error. We're going to need N, our X0, our mean of X's, and our SXX. Okay, so let's go to MATLAB. First of all, I've already loaded it in, so I have my dist and my speed. So speeds. So first of all, I will fit my reg stats. Give the y first, which is the distance, and speeds. That will bring up my dialog box. And I'm going to need, I'll get the coefficients. At this point I will need t-stats to be useful. I'll need the mean square error. And that's all I'm going to need for this one. Let's click OK. And there's all the stuff being created for me. So first of all, what I'll do is I'll work out this bit, which is the y hat, which I'll need for both one. So I'm going to need the first coefficient, second coefficient, and x0 is 15. So first of all, x0 equals 15. Let's look at the betas. I've got our values there. So I'm going to call it y hat. And that's going to be beta, the first beta value, which corresponds to my beta 0. So beta 0 hat is this minus 17, which is what this gives me, plus beta 2 times x0. So if I say, for example, beta 1, that gives me that first number, which is my intercept, and my beta 2 is my slope. So I basically said, I'll take my intercept plus my slope times what my x0 was, which is 15. So I get the point prediction is 41.4070. So that is this bit here. So I'll need t star next. So let's call it t star. And I'm going to get that. I'm going to have to use a t inverse. So let's think about what we're doing here. I want to get the t star and the minus t star such the area in here is going to be 0.95. So basically I can say what point such the area to the left is 0.975. So the question is, which t distribution do I use? Well, altogether you have n observations to do this, and then to do this estimate I have to estimate two things, beta 0 hat and beta 1. So my degrees of freedom now is n minus 2. So if I go back, before I get my t star, let's go n. What does n equal? Well, it's the length of dist. So n equals 50. So our degrees of freedom is going to be n minus 2, which is 48. We can check that because remember we've produced a thing called t-stat. If we look here, degrees of freedom agrees 48. So now I'm on the right direction. So now I want t star. That's going to be t inverse 0.975 48. So 2.0106. Excellent. So what's the next thing I need? I need the SE. So this is the sample standard deviation of my residuals, which basically, if I look at MSE, is the square root of that. So SE is going to be the square root of mean square error, which is that. Now the rest, I'm going to need x bar, so I'll call it x bar, and that's the mean of the x's, which in my case is the speeds. And I'm also going to need SXX. What's that? I basically take every value of my x's, the speeds, I minus the x bar, and then take each of them and I square them. I want to do each one element-wise, so I use the dot. So we'll square them all. So this is basically the first value of speed minus the x bar, the 15 squared, etc. And I'm going to take all of that and I'm going to add it all up. So I get that value there. So let's call that SXX. So should have pretty well everything I need now. So let's just put that over to the side so I can put it in. So I need, for the first left one of this, I'm going to go y hat minus t star times SE times the square root of 1 over n plus x0 minus x bar squared divided by SXX, close the bracket. So there's my left point, here's my right point. Copy that. So my left point and my right point. Now the prediction interval, it's going to be pretty well exactly the same, but I can have an extra one in here, so I can basically use arrow key up and put in 1 plus and do the same thing but minus. So this is my left endpoint, this is my right endpoint. So let's grab the left first. And then the right one. Excellent, all done.